This is a formula which I won't be deriving, but it makes job very easy for you to calculate the areas of polygons. So polygon means any figure, any geometrical figure which has more than 3 sides, 3 or more than 3 sides, right? So it covers triangle, quadrilateral, pentagon, hexagon, everything that is to follow. So you have a polygon which is n-sided, right? In my example, the polygon that I have taken, the formula for which I have written is n-sided. So you have the first vertex having coordinates x1, y1, the second vertex having coordinates x2, y2, right? Likewise, you have, this is your first side, you'll have a second side. So likewise, you'll have n sides, right? So this is your n sides. This will be your nth side, and the coordinates of your final, vertex will be x and y n, right? So you have x1, y1, x2, y2, you'll have x3, y3, x4, y4. Likewise, you have x and y n, right? So the area that this closed polygon will cover, so basically this area that it covers is given by this formula. This is called the staircase formula. So I would like you to remember this because it will help you a lot during examinations. So what you do is basically you write all the x coordinates starting from x1 and going until x1, right? So x1, x2, x3, x4, so on, xn, and you come back to x1 again, right? Likewise, in this column, you make all your y1s. So y1, y2, all your y coordinates, y1, y2, go on up to yn, and then end on y1. So remember, you have to start on x1, y1, you have to end on x1, y1. Now, treat them, so go as a staircase. So x1, these arrows, that the pink arrows show the direction. Do x1, y2 minus x2, y1, right? So go like this, go along this pink arrow, x1, y2, then return along this pink arrow, which is x2, y1, and put a minus sign in the middle, right? Put a plus sign, and then likewise, then forget about the upper part. Then start with pivot at your x2, and then go along this pink arrow. You'll have an x2, y3. You'll have an x2, y3 here. So x2, y3 minus x3, y2. So x2, y3 minus x3, y2. Likewise, keep going. Then forget about this. Then pivot x3. Do the same thing. And finally, when you come to x1, then you do x1, x and y1, that is your final term, x and y1 minus, you come back along this path. So basically this is your direction, x1, x and y1 minus x1, yn, right? So when you finally put all of this, when you finally put all of these, or add all of these quantities, and then put a mod against it, put a mod, because if you get something like a minus 10, but area can't be negative, right? So that is the reason why you put a mod. You put a mod against this quantity and multiply it with a half, right? So this is the formula for the area of polygon. So from this only you will get triangle, quadrilateral, everything. So if you have the vertices of a polygon in hand, you can always use this formula to calculate the area of the polygon. We are not going into the derivation of this, but its usage is very easy. The pattern in which the formula is written is very easy. So I hope you found it informative. Let's move on to the next subsection.